Okay, so today we're starting on this slide. We're going to talk about comparing data using measures of central tendency and dispersion. We have the closing prices in dollars of two stocks for the first 5 days in February are shown below. What are the range and mean of each set of data? Use the results to compare the data sets. So we only need to find two things. We need to find the range and we need to find the mean. And I think you guys are pretty comfortable in finding them, so I'm just going to go ahead and give them to you for this set. You'll be finding them on the next set. So for stock A, when we find the mean, by adding them all up and dividing by 5, we find a mean of 32, and we find a range of 22. For stock B, we also have a mean of 32, but we have a range of 8. Okay, so when you're investing in stocks, you want the average price to be fairly high, right? You want, if you purchased a stock for a low amount and it's grown, then your money has grown, and you want that stock to stay high. You don't want it to fall. So when we're looking at stock A and stock B, they both look like, well, these are equally good to invest in because they both have the same mean. They both have the same average value. However, the range for stock A is 22, while the range for stock B is only 8. What would be a better range? Do you want a bigger or smaller range when you're talking about investing in stock? Gretchen, what do you think?
I want to say smaller.
Smaller. Why do you think smaller?
Because you want them, I'm going to say bigger.
Okay, now you change it to bigger. Okay, why? Anyone else? Any ideas about that? So we just have one very indecisive person. Okay, think about this. Look at stock A. Sometimes stock A goes clear down to a low price of 25. Sometimes it shoots way up. If you were kind of, say, an older person, you were going to retire soon, you wanted to get your money out at any given time, what if the stock went really low on stock A? What are the chances of that happening on stock B? Which one has a bigger chance of hitting a sudden low? Sophia? Stock A. If the range is larger, it means there's more variance in the stock. So it might shoot up really high sometimes. It might go down really low sometimes. It's very unpredictable. It kind of goes like this, but whereas stock B has a nice straight kind of, has a few little ups and downs, but not as many. So stock B would probably be a better one to invest in because there's less variance. So what you would say here is, if say you had this problem on the Keystone and it was an open-ended question, you would need to write some kind of a paragraph explaining this. You're just going to find measures of center and then talk about them. So you would just say, this is really obvious to state, but sometimes you just need to state the obvious. The mean of both stocks is the same. But stock A has more, I'm going to say more variance in its prices. I'm going to say as evidenced by a larger range. And then I might actually go on to say, I can get pretty wordy when I'm doing these kind of things. I might go on to say, therefore I would invest in stock B because it's more predictable. But I'm not going to write down that. You should probably write what's here so you have an idea what it is you need to write in these kinds of problems. The next slide is one for you to try. I'm not going to turn there on the board yet because some of you are still copying that. So I want you to find the mean and the range of those two data and compare the two stocks and think about which one you would invest in as a result of the data. Okay, let's at least collect the data, and then we'll talk about Which one is which? For stock C. What did you get for the mean, Katie?
4.2.
Good, 4.2 is correct. How about give us the range as well, Katie?
6.
Good. Range of 6. Okay, now let's move over to stock D. Maddie, what did you get for the mean for stock D?
11.2.
Good. And the range?
20.
Good. Okay. Adam, do you agree with all those means? Did you get all that? Okay, what did you write as a comparison? Or if you didn't write anything, what can you say as a comparison?
C has a lower range than stock B.
Okay, I'm just going to repeat that so we can hear it on the video. Stock C has a lower mean and lower range than stock D. Okay, so he's saying they're both lower. So what does that mean in terms of investing? If you were going to invest in a stock, volunteer for this one, what stock would you invest in and why? There's no wrong answer on this. Zan? Okay, why would you invest in stock C? Okay, but remember, a smaller mean, though, means that you're not making as much money with that stock. But you think that the smaller range would still, you like the predictability. So you'd be a safe investor. There's two types of investors, people who like to stay very safe. My parents were always that way. They liked very safe investments that they knew were just going to stay the same all the time. And then there are people who are more high-risk investors. Tina, what would you do? Would you do the same?
Stock B because there's a wider range and because there's a wider range and the numbers are all higher, so there'd be the numbers are higher, so there'd be a greater chance of you having a higher whatever you get paid from the stock.
Okay, so the numbers are higher, so you like this higher mean, but remember a higher range means the stock is less predictable. In general, the younger you are, the more high risk you can afford to be, because stocks all kind of go up and down over time, but if you're young and you don't need your money out right away, you can take more risks. So they usually encourage younger people to invest in stocks that have a higher rate of return, but have more predictability. And then as you get older, you transfer your stuff into lower risk stocks where you might not make as much money, but you know it's not going to take a sudden dive right when you need it. Okay, take a look at this. This is a slightly different spin on this. We have a line plot instead. Line plots are just like dot plots, except instead of dots, they have a line and X's. It's the same idea. It says the results of a survey on the number of televisions in students' households are shown in the line plot. It asks us to calculate the mean, median, and range of the data, and then also asks how we can tell from the graph that the mean and median are equal. Okay, so first, let's take a look at how we would calculate the mean. This means that 2 people have 1 television in their household. 4 people have 2 televisions. There's 1, 2, 3, 4, 5, 6 X's here, so 6 people have 3 televisions. So when we're trying to find the mean, we have to add up all of these numbers. We have 2 1s, so we have 2 people who have 1, or 2 times 1, plus 4 people who have 2 televisions. We could also go through and do 1 plus 1 plus 2 plus 2 plus 2 plus 2, but it's easier this way. There's less to keep track of. I'm writing this out, and I'd like you to write it down this time so you can see how to do it. You do not need to write down these details every time. You can just go through on your calculator and quickly type in, okay, 2 times 1, 4 times 2. You can do that quickly without writing it all out. But for this time, there are 4 people who have 4 televisions, 2 people who have 5 televisions. And then how many data values do we have altogether? Lacey? We have 18. So if we count the X's, there are 18 X's. So there were 18 people surveyed. I'm out of room, so I'm going to write that over here. Let's see. Okay, and then I'm going to find out what that equals. So if I did this all on my calculator, which I'm not going to go through the process of actually doing right now, On your scientific calculator, you can enter this exactly as it is, and order of operations will keep track of it and give you the right answer. If you're using the calculator on your phone, if you have your phone turned like portrait style up and down, usually you don't have a scientific calculator. If you just try to enter this in, it's not going to do it correctly. It'll do 2 times 1, and then it will add 4 before it multiplies by 2. But you know, if you turn your phone sideways, you usually get that scientific calculator. You can just enter the values in. So when you do all this, you get an answer of 3. So the mean is 3. To find the median from a line plot, you want to find the middle value. This is actually, if we look at this line plot, it's very symmetrical. We have 2 on each outside, 3 on each inside, 4 on each one, and in the very center, we have a tall column. So it's very symmetrical. What would the median be? That's pretty easy to see. Athena?
3.
The median would be 3. Sometimes they're not easy to see, and you kind of have to count from the outside in to find which value would be the middle. But in this case, the median is really easy to see. The median is 3. And then it asks us in part B how you can tell from the graph that the mean and median are equal. When your graph is perfectly symmetrical like this, then it's always going to have the same mean and median. So when you have a symmetrical graph, you know that they're going to be the same. The graph is symmetrical, so they are equal. Okay, the next slide. Just want to take a look at this with you before you try it. The graph is not symmetrical, so you can be pretty sure that the mean and the median are not going to be the same. Which do you think, just kind of make a guess before you start this, what do you think would be higher on this, the mean or the median? Just kind of think about that and keep that idea in your head, and then do it, and we'll see which one is actually higher. Okay, so take a couple minutes to work on this one. Okay, let's start to go over this. I think a lot of people are done. So if you're not, we'll just kind of go from where you are. Adam, what did you get for the mean?
20.8.
Good, 20.8. Okay, how about the median? Same?
21.
21. And what about the range, Rosa?
5.
5. Good. A couple of you asked me about range. What numbers do you subtract? Do you use the number of x's or these numbers? You use the numbers along here. A dot plot is just, or a line plot is just a way of quickly listing all the numbers. If this were a list of data, we would have 19, 19, 19, 19. We'd have 20 written 5 times, etc. So these numbers along the bottom are our numeric values. That's what tells us how many students are in each homeroom. So the range of students in each homeroom is the largest number, which is 24, minus the smallest number, which is 19. Okay, B asks how you can use the line plot to determine whether the mean and median are equal. Volunteer for that one? Lacey?
The graph isn't symmetrical, so one is likely.
Right, the graph is not symmetrical, so they're most likely not the same. We would say that this graph, it's shifted a little more to the left. So there are more homerooms with a smaller number of students than there are a larger number of students. So we would expect to get both a mean and a median in the lower end of the range than we would in the upper end, because we have more x's. Okay, along those lines, let's look at the next problem. The results from the same quiz given to 2 different classes are shown in the line plots. And this is worded kind of strangely, I think. I think this came out of your textbook. Which class has a higher standard for being in the top half of the quiz scores? In other words, which class did better overall on the quiz. Sophia? Class B. Class B has more X's along the higher values than Class A does. Class A, however, is very symmetrical, so there's kind of an equal number of people who did poorly as super well, and most people fell in the middle. So that's kind of an average class. Class B had more students who got better grades. So if we look at the median of each class, the median of Class A is actually pretty easy to find. Can anyone tell me what they think the median is without counting X's? Gretchen? It would be 3.5 because columns 3 and 4 are the same, so the median has to be in between the two, which would be 3.5. So the median of Class A is 3.5. The median for Class B is not as easy. We can't just look at the graph and see what that is. So you kind of have to, you're kind of counting from the outside in. What I do when I'm finding the median on a line plot is I count how many X's there are. So for Class B, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We have 21 X's. So did I count that right? It seems like it should be 21, 2, 3, 4, 5, 6, and 6 is 12, and 5 is 17, 18, 19. Yeah, there's 21 X's. So it's going to be, what X would be the middle X? There's 21 of them altogether. Which one is the middle? What's half of 21? 10.5. So if we had a list, half of it would be 10.5, but we would actually have that middle number would be our 11th number because there would be 10 numbers on either side of it. So I would just count through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11th X falls at a quiz score of 5. So the median for Class B is a 5. And we could also go through to find the mean. And so it just asked you by comparing line plots, how can you tell which mean is greater? Well, B has more values to the right, so we would assume that the mean and also the median would be higher because the data is shifted to the right. Okay. Next one is one for you to try. Let's see how much time we have. We have just a little bit of time left. So I want you to take a look at that one and try it. This one does ask you to find the mean as well as the median and then tell which data set. Just think about before you start which one you think is going to have a greater mean and then answer the question and see once you found your data. We have it.